see why I should never be left alone. I was going to make a very simple select example, and it turned into something very, very different. So I sort of ripped off bits of my HTTP server and improved upon that and made a very generic framework for applications. Yay. So this makes heavy use of function pointers. It makes heavy use of structs and the object-oriented concepts that we've covered, where you have structure inheritance. So the idea here is you'd have a main function, and you'd make an application. And an application is very simply just a set of functions. So if we actually go look at the application, we'll see there is a struct here, which deals with creating the configuration, destroying the configuration, setting up the configuration, right? So all the command line arguments and all that, that's what that would do. Function to actually act as the real main, so what's the work going to happen, and then a function that you can clean up. All of these except run are optional, so if you provide them, great. If you don't, that's not a problem either, just set them to null. And this expand path is needed because if you go to open up a file, my configuration file is set to tilde, which is, and this should actually be .echo server, but I'm going to do that right now. But traditionally, things with dot in the file name, when you do a file listing, they don't show up if the dot is the first thing. So we put configuration type things in with a dot directory. I just missed that. So tilde means my home directory. But if you try to open this up, it won't open with like open or fopen, that kind of thing. So we need to expand the path. The code exists in application. You can go take a look at it if you really want to. It's this. You can delve into it if you want. And then we just say we want to run the application. We pass in argc, argv, the environment variables. Right? You have to do that to get environment variables. The config path, and I'm passing in null, and I don't remember what that last one is. But we'll take a look because we go to application run. So application run, app data. So I have no particular app data that I want to keep track of. So we go through, and if we're supposed to create the configuration, we create the configuration, and then if we're going to set it up, we set up the configuration, and otherwise we just set the config to null. The configuration, I'm not going to go through all of it, but it is relatively simple as well. So there's the config header file. We're using the inheritance. You can't have just an empty struct, so I had to put something in, but there's no common configuration for anything. And the Echo server, which is what I'm making, has its own configuration thing. So it's got default ports, whether or not we're forcing connection, the backlog, whether or not we're verbose, the environment variables we're going to use. And no struct though. The struct is actually hidden. It's a type of DC server config, right? So it has, the Echo server has no particular settings itself, but all network servers have something in common, and that would be here. So they all have a port, a connection, forcing the connection, the backlog, and verbose. No code associated with any of this. It's just the header file. Then the server config here, the interesting one is the setup, where first off, when we create it, we set the defaults. So those defaults that were in here. And I actually don't know why I put these up here. I don't think it makes sense. I guess you could put them there just so people could find out where they are, but logically speaking, we can just throw them in here. So the default ports and all that. And then we read, so we have the defaults all set, so your port is set to 80, you're not forcing the connection, you can have 5 backlog, and we're not verbose. Then we overwrite that with anything that came from the configuration file, if we're using a configuration file. Any of the environment variables can override it, and we can then set it based on the command line arguments. You can read this whole file. So this is basically when you did the HTTP server. I did my own. I never finished it. I never showed you the code, but I ripped off a bunch of code for it for this. So the idea here is I have the concept in the application that there is configuration. And I have this concept of a general server. We'll go through that too. So I have a general application, I have a general server. The general server has configuration, but neither of these mandate how the configuration is actually made, right? So it doesn't say you have to use libconf. It doesn't say that you have to use command line arguments or anything like that. That's left up to the specific application. So I'd like to abstract this a little further, but I'd have to write a few more applications with it to be able to figure out what my abstractions would be. Generally, if you're going to try to abstract things, do them in threes. Because you can get a reasonable amount of idea of what it's going to look like by kind of guessing, but you'll get it wrong. And then the second one will help you fix all the mistakes, and then by the time you get to the third one, it should hopefully be fairly generic now. So, yep, I wanted to keep that open. So we deal with the configuration, and then once the configuration's deal with, we run it, which is our actual real main, what you would normally have in main. So that is this. And in this case, I'm writing a server, so I'm going to make use of server-y stuff. The server needs a socket, so I'm going to open that. You can configure that yourself. And again, I'd have to write more servers to make a better abstraction with this. This is a reasonable first pass. And then I run the server. That's some generic code. It runs server-y stuff. That's obviously run on a thread. And then I'm going to join the thread so we hang until it's done, and then I've just got this debugging stuff. I haven't worked it all out yet. And I'm not sure about the pthread exit here. I was using some example code, and it looks like it truly does exit, and I don't necessarily want that for this. So I'm going to have to debug that a little bit further, but I'm not too worried about it right now. So the server run, it takes a DC server config. So if we go to the server config, right, that's this thing here. We've seen that already. And it takes the server file descriptor, the thing we already created. And it takes this connection handler called handle connection. That's going to get called every time we go to accept a connection. So we'll come back to that later. So in the server, which is a very generic server, it uses a finite state machine. That's new. I did not do my HTTP server with the finite state machine. So the finite state machine runs doing its finite state machine stuff. First off, we call the DC server run. It creates the thread, sets it all up, and runs the that function down there. And obviously I haven't finished everything, but this is far enough along that I can show you. So we call the finite state machine run. We've got all of our different things. So first I'm going to initialize my connection, then I'm going to bind, then I'm going to listen, then I'm going to go into accept. Accept's just going to sit in a loop. Any of those can go to error, and if we error, we're going to exit the machine. Other than that, we don't exit the machine. Moving from init to the finite state machine to our init, and then ultimately we run the finite state machine. I have also made some changes to the finite state machine, so I will not be publishing that. Or I will publish it. You'll have to be careful because it's going to break. It's an API change. It will break your finite state machine code. So we run the finite state machine. Added this verbose flag. That's the big API change. So we can print out what states we're moving between, which helps for debugging. So the server init just sets up the data, the socket for what we want. We move to bind, which is going to, if we're going to override the connection or force a connection, we do that, and then we bind. and then we move to listen, and it's going to listen, and then we move to accept, where it just sits in a loop calling accept, and every time it accepts the connection, it calls that handler function that we passed in. Right? So that was this handler function here. And that's the last function we have in this file, basically, which is I'm going to read an HTTP request. Again, you can just go through that code. So read the HTTP request, and then we close it, which means the other side is going to be unhappy because we didn't return what we're supposed to, but that's fine. Free up the request that we got, the string, and we print it out. So if I were to run this, which is actually already running, if I ran this, so I'm moving from my different states, right? That's the finite state machine init to rnit to bind to, actually, we can see them because I documented it because I'm smart. If I go to the right place in the server. So the states are 2 to 3 is init to bind, 3 to 4 is bind to listen, 4 to 5 is listen to accept. And then if I were to just run something here, we'll see it came in on, actually I didn't print that out anymore. So we see that we're getting slash with HTTP 1.1, and there's the information. Do it again, we'll get that. If I were to start a web browser, I could do the same kind of thing. I think I've got one here, just localhost, and we'll see there's the information we're getting on localhost, right? Much larger from an actual web browser. So yeah, so this is really modular, right? The state machine makes it modular, but also these having to pass these function pointers, right? So this one simply sets up the app. This one simply sets up the server. This one simply handles a request. So right now, the way this is done is it's a serial server. It handles one request at a time completely, and then it waits for the next connection. This is awesome for your very first assignment with the tic-tac-toe server, where you only had to handle one client making a turn at a time. But now that we've got multiple clients, that's going to be different. I haven't coded the select yet, but just to get you started on what it would look like, this piece of code here would now add that to the FD set, and I'd have another thread running. I figure I'll have another thread running that's just going to be sitting there doing the select stuff and all that. So the same server, the only difference between making a one that handles serial or doing a thread pool or using select is just what we do in this handle collection. So it's all nicely broken up into very discrete pieces.